The intermediate value theorem says that when you have a continuous function, basically a continuous function is a function that does not have any breaks. I can just set my pencil down and just coast along the function without any jumps, skips, or stops. When you have a continuous function, if you pick any 2 points on that function, I'm just going to pick this point here and this point here. Let's say this first point is at A, the second point is at B. And you have your y value that goes with that. That's f of a. Now f of a is just the y value that corresponds with point A. And you've got f of b. That's your y value that corresponds with b. That in between these 2 points, A and B, for all of these y values, every y value that's in between f of a, f, and b, and you can see all these y values here, there is an x value, and that x value we could call c. At this x value, there is an f of c that reaches all of these y values. To put that a little simpler, let's just go ahead and pick a few points. Let's say this is point 3 and this is point 5, and at x equals 3, we've got a y value of 1, and at x equals 5, we have a y value of 4. All this is saying is that for x values in between here, we have some y value for all these values. So in other words, we have a value at 2, check. We have a value at 2. We have a value at 3, check. And you could do that for any value that is in between these two y values. There is an x value in between these two x values that reaches that part on the graph. The intermediate value theorem can be very helpful in helping us find zeros. And how we're going to do that is you're going to be looking for a different y value from positive to a negative. See, look at this point here, negative 3, 1. Here we have a positive y value. Let's look at this next point at negative 2, negative 2. Here we have a negative y value. Since this is a continuous function, you know that between your positive y value and between your negative y value, there has to be a 0. In this case, that 0 is going to be right here. Let's take a look at the other 0 that we have. Here we have a point at 3, negative 2. That's a negative y value. Now here we have a point at 4, 1. That is a positive y value. So since we have a negative y value and a positive y value, we know that somewhere in between those two values there has to be a 0, because in order to get from the negative to a positive, we have to cross 0, and that 0 is going to be right here. So if you apply the intermediate value theorem, looking for a positive y value and a negative y value, you know there has to be a 0 in between. Alright, let's do a quick example problem. Here we want to determine between which consecutive integers the zeros of the function are located on the given interval. Remember, consecutive integers, those are just integers, those are whole numbers, positive or negative, and consecutive just means in a row, so 1, 2, 3, 4, 5, 6. So between which consecutive integers there is a 0. Remember what we just talked about with the intermediate value theorem. You know, on your graph, when your one y value is positive, one y value is negative, then there has to be a 0 in between. So here's our function, f of x equals 2x to the 4th minus 3x cubed plus x squared minus 3. And here's our interval from negative 3 to 3, and these brackets mean they're included, right? So all our integers in here are negative 3, negative 2, negative 1, 0, 1, 2, and 3. So to use our intermediate value theorem, we want to plug each of those values into our function and look for where we have consecutive integers. One gets us a positive y value, one gets us a negative y value, and then we'll know there's a 0 in between. So I went ahead and plugged in all my integers in here. So I have f of negative 3 all the way through f of 3, and I got my answers, and I'm looking for a switch in these y values from a negative to a positive. So looking here, I have f of negative 3 equals 249, f of negative 2 equals 57, f of negative 1 equals 3, f of 0 equals negative 3. So here I have a positive 3 at negative 1, and I have a negative 3 at 0. So this here, I know the intermediate value theorem applies, and there's going to have to be a 0 between those two numbers, those x terms of negative 1 and 0. So I know between the integers of negative 1 and 0, there is going to be one of my zeros, because I'm switching from this positive to this negative, and it has to pass through 0. All right, continuing on, we've got f of 1 equals negative 3. So here's a f of 0 is negative 3, f of 1 is negative 3, f of 2 is positive 9. Here I have another switch from a negative to a positive at my x values of 1 and 2. So I've got another 0 in between 1 and 2. And then here I have a positive 87, so there's no switch here. So I know there's two zeros that fall within these numbers, this interval here, and they fall between negative 1, 0 and 1 and 2. So these would be my two intervals where I'm going to find zeros.